All right, hey there, Math 2150. So we are starting a new chapter today, and it is chapter 4. 4.1 talks about antiderivatives, and this entire chapter builds. So I need you to stick with me throughout these next 5 sections because 4.1 builds on 4.2, which builds on 4.3, and so forth and so forth. So I need you to stay up with me, and I really wanted to make sure that you had a good 4.1 video to get you ready for the rest of the chapter. Okay, so to start off, I've given you 2 problems. Okay, and if you take a look up there, you may say, Miss Floyd, that's not what you usually give, and it's not. This is exactly not what I usually give. If you've taken a look up here, I have given you the derivative, and I want you to tell me the problem. And so if we were in a traditional class, I'd give you a little bit of wait time, but I'm going to go with it. If the derivative is 3x squared, guys, then I hope you know that the original function is x cubed. So x cubed, the derivative is 3x squared. So if you work it backwards, 3x squared, the original function would be x cubed. Okay, and so I want to talk about how we get from here to here, okay, working it backwards, because that's technically what an antiderivative is working it backwards, okay? So we are doing the problem backwards. So usually the first thing that I get kids to say, and you should be able to see this pretty automatic, is take a look at the exponent. So the exponent down here is 2. The exponent when I work backwards is 3. And so how do I get from 2 to 3? I simply add 1. So when finding the antiderivative, so let me write this out. When taking or finding the antiderivative, guys. So we're no longer looking at derivatives. We're now looking at antiderivatives. This is the third big idea of calculus. The first big idea was limits. The second big idea was derivatives. And now the third big idea is antiderivatives. So when taking the antiderivative, or taking the antiderivatives of a function, and it shouldn't be plural, it should just be the antiderivative of a function, okay, the first step, like we said, is to add to the exponent. Add 1 to the exponent. So take a look up there again. The exponent was 2. When I worked backwards, it was a 3, so we added 1 to the exponent. But if you take a look, no, we didn't just add 1 to the exponent. Okay, so the coefficient in the original problem was 3. And the coefficient up here in the answer when working it backwards is an imaginary 1. And so how would we get from 3 to an imaginary 1? Well, if you notice, what's the exponent? The exponent is 3. So you simply divide by the new exponent. So divide by new exponent. Okay. So think about it. If you have, let me show you the correct notation working it this way. So let me go back to maybe a black pen. This symbol right here is the antiderivative symbol, okay? It's an elongated S, it's the antiderivative symbol. So if I take the antiderivative of 3x squared, which is what we just looked at, with respect to x, okay, so I have to tell you what I'm with respect to, it will equal, let's take a look. What did I say do? Divide by the new exponent. So if you think about it, guys, the old exponent was 2. The new exponent will be a 3 because we're going to add 1 to the exponent. So the answer would be the coefficient, which is 3. 3 divided by the new exponent, which is also a 3, x cubed. Okay? And so if you take a look at it, 3 divided by 3 is going to cancel, and the answer would just be x cubed. Okay? So let me talk about this, though. If you looked at the video on the Khan Academy, which I sure hope you did, if I go back up here to my original problem, x cubed plus 1 could have also been the answer, because take a look, x cubed, the derivative, not antiderivative, guys, the derivative of x cubed is 3x squared, and we know the derivative of 1 is 0. The derivative of 10 is 0. The derivative of 100 is 0. The derivative of any constant is 0. And so because we don't know what the constant is, every time we take an antiderivative, we have to put plus c. Side note, you have no idea how many points I lost as a calculus student in college because I forgot to put my plus c when taking the antiderivative. So please remember to put your plus c when taking the antiderivative, okay? So let's take a look at number 2 that I wrote up there from the beginning. So if I use the correct notation, the elongated s, that means antiderivative of what? Of 4x with respect to x equals, the coefficient is 4, leave the coefficient as 4. You're going to divide the coefficient by the new exponent. The exponent over here was an imaginary 1, which means the exponent is going to become a 2. I was trying to give you some wait time in that. You're exactly right. It's going to be 2 because we add 1. Okay, so our exponent is 2. X squared because our new exponent is 2. And you're exactly right. 4 over 2 is just 2x squared plus c. That's exactly right. So if I go back up here to try to make you realize, if I gave you 2x squared, then you've, for the last 4 months, or 3 months at least, you've been taking derivatives, and you know the derivative of 2x squared is 4x. Okay? So, like I said, we're now working it backwards. So really the only thing I can do in this entire section is just to give you examples to make sure you know how to take an antiderivative. So if I give you a couple of examples, okay, and I'll start off as easy as I can. Number 1, the antiderivative of x cubed with respect to x. Okay. So, the exponent is 3, so the exponent is going to become a 4. So it'll be 1 over 4 x to the 4th plus c. There's your answer. That's all. I added 1 to the exponent. I got a 4. The imaginary coefficient was a 1, so it's 1 over 4 x to the 4th plus c. Let's go again. Number 2. What about x to the 5th? With respect to x. So the exponent is a 5, so it's going to become a 6, so it'll be 1 over 6 x to the 6th plus c. You're exactly right. Let's go again. Number 3. What about the antiderivative of 2, oops, I don't know what happened there, of 2x to the 7th with respect to x? So the coefficient is going to stay 2. The exponent is a 7, so the exponent will become an 8, which means we're going to divide by 8. X to the 8th plus c. And then, of course, guys, you need to clean up your fractions if you can, which means reduce your fractions. So 2/8 x to the 8th is the same thing as 1/4 x to the 8th plus c. Okay? And so if your question should be, can I do it with multiple terms? Well, you're exactly right. If you read over the notes from the presentation, from the lesson, the PowerPoint, then you saw that if you have, let's say, 3x to the 4th plus 5x to the 3rd minus x squared minus 8x plus 2. Let's take a look at that. And we're going to take the antiderivative of this entire thing. So I put parentheses around it to say I'm taking the antiderivative of the entire thing with respect to x. Okay? And I'm just going to come right below it just because I don't have space. So 3x to the 4th. Again, the exponent is a 4, so the exponent will become a 5. So it'll be 3 over 5 x to the 5th. Okay? Move to the next piece, plus 5x to the 3rd will become 5x to the 4th. And yes, you're exactly right. We need to divide by 4. Very nice. Minus x squared. Well, x squared will become x to the 3rd. There's an imaginary 1 in front. And we need to divide by 3. You're exactly right. Okay, so simply every single time I add 1 to the exponent and I divide by that exponent. Minus 8x. Well, think about it, guys. That x is an imaginary 1, has an imaginary 1 exponent, which means the exponent is going to become a 2. So it'll be 8 over 2x squared. Okay, and then this next part, sometimes kids get confused when you see a constant. Okay, 2 is a constant. It's a number by itself, which makes it a constant. The antiderivative of a constant, well, a constant doesn't have a variable, which means the exponent is 0, which means when you add 1 to an exponent of 0, you get an exponent of 1, which means that the antiderivative of 2 will just be 2x, guys. Okay, and then don't lose your points, put your plus C, okay? And so then the next step, guys, would just be to clean it up. You've heard me say that over and over this semester. And when I say clean it up, that pretty much means reduce fractions if possible. And the only fraction that we can reduce is right here, which means it would just be 3/5 x to the 5th plus 5 over 4 x to the 4th minus 1. Well, we don't have to have that 1. We can just put x to the 3rd over 3 minus 4x squared plus 2x plus c. Side note, for those of us that really struggle with math, that just need to make sure you understand this. If you have 3 over 5 x to the 5th, that's the same exact thing. That's equivalent to 3x to the 5th over 5. Why am I telling you this? Because you can put that x to the side of the coefficient, or you can put that x in the numerator. Both of these things are equivalent in mathematics, okay? And so there are a couple of other big ideas that the PowerPoint really wants you to make sure you understand. And one of them is this one, okay? So put a star beside number 5. It's going to give you the antiderivative of, let me take a look of what it's got. The antiderivative of, yes, the antiderivative of 1 over x. Okay, and so if we're taking the antiderivative of 1 over x, this is a big idea. So let me put a little highlight mark here. That way you know. The antiderivative of 1 over x. So if you work it backwards, okay, if you think backwards to chapter 3, or maybe it was chapter 2, what function gave me a derivative of 1 over x? Well, I'm sure there's somebody watching this video that remembers that the derivative of the natural log of x was 1 over x, which means the antiderivative of 1 over x is the natural log of x plus c. Okay? And hopefully, guys, you remember that you cannot take the natural log or the logarithm of a negative number, which means the antiderivative of 1 over x with respect to x equals the natural log of x if they tell you x is greater than 0, because if x is greater than 0, x is positive. However, the antiderivative of 1 over x with respect to x equals the natural log of the absolute value of x plus c. If it doesn't give you x has to be greater than 0. Because, guys, if it doesn't tell you x is greater than 0, x could technically be positive. And we can't let x be positive because then, we can't let x be negative because if x is negative, we can't take the natural log of it. That's why we have to throw absolute value bars around that, okay? And so the last big idea from this section is what about the antiderivative of maybe 3e to the x with respect to x, okay? So if you think about it, guys, when we took the derivative of e to the x, so this is actually not what I was hoping, but this is fine. 3e to the x, the antiderivative will still be 3e to the x plus c, okay? And the reason is, if you remember, the derivative of e to the x was still e to the x. Let me say that again. The derivative of e to the x was still e to the x, which means the antiderivative of e to the x will also be e to the x. Now, if I show you number 7, this is what I was hoping came out in number 6, but I wrote a poor problem. If you look at this one, 2e to the 2x with respect to x. Here's what I was hoping. If you remember from chapter 2, the derivative of e to the x was e to the x, but the derivative of e to the 2x was not e to the 2x. It was 2e to the 2x, okay? And so the derivative of this will actually be 2 divided by the exponent, the coefficient of the exponent with the x. So it'll be 2 divided by 2e to the 2x plus c. And so this will just be e to the 2x plus c because that simply divides out. Now let me give you one more example similar to that. What about 4e to the 3x, okay, with respect to x? So the coefficient is 4, so the coefficient is going to stay 4. You're going to divide by the number with the x, and so you're going to divide by 3. E to the 3x plus c, okay? So there is just several examples to try to help you get started with antiderivatives. Make sure to pay attention to your notes and the PowerPoint because the PowerPoint provides several